Hello everyone, this is your Pioneer Mathematics and Physics class. I want to continue from where we stopped on circle geometry. The last time we treated the first part of the circle geometry, and that was the first theorem. So to solve questions, that was where I stopped. I want to continue that topic now, so that you know how to solve questions in case you meet any question on the way. So the first question to be solved here, that will be the first example of the day. And let's see how that question will be solved. So the first question here, like I said, the first example. So this is example 1. The question says that the radius of a circle is 10 centimeters. The length of a chord of the circle is 16 centimeters. Calculate the distance of the chord from the center of the circle. So to solve this, what do? It's very simple to solve. So just go straight to draw the circle. Solution to number 1. Solution. So to draw the circle, you have to draw the circle first. Let's draw that. Pick the circle. So we have the circle here. Circle is drawn. Next thing is draw the chord. The chord is drawn. Chord. Now we're told again that it has a radius of 10 centimeters. So if here is the center, we have the radius here to be 10 centimeters. Then we need to draw also from the center to the circumference. To the chord. So here now, what do we have there? We have right angle here. Here is 10 centimeters. The whole length here is 16 centimeters. And we have to find G. From the question, it means that R equals 10 centimeters. L equals 16 centimeters. And we don't know R. But from what I gave you in the formula, that we have D squared plus L over 2 squared equals R squared. Because we are looking for that side, so I have to write that one first. Why? Pythagoras theorem. So here we have D. Oh, sorry, we are looking for D. I wrote R, D question mark. So we have D squared plus 16 over 2 squared equals 10 squared. So D squared plus 8 squared equals 100. We have D squared plus 64 equals 100. This squared equals 100 minus 64, that is d squared equals 36, d equals square root of 36, and the final answer is 6 centimeter. Finally, you say that therefore the distance of the chord from the center of the circle is 6 centimeter. That's all about that. Let's pick number 2 question. Number 2 question is loading. Copy. So we're going for number 2 now, so that we can be happy. So we have number 2 here. This is number 2. Example 2 now. Example 2. Now we have example 2 here. According to the question, let's first draw our circle so that we have the circle here. Let me make it bigger. Yes, we have the circle here. So we have our solution here. From the question, the question says that the distance of the center of a circle of radius 5 centimeter from the center of the circle is 4 centimeter. So, the distance of a chord of the center of a circle of radius this from a chord of the center from a chord. That's the way it should be. There's a mistake in the typographical error of a chord of the circle is 4 centimeters. Calculate the length of the chord. The length of the chord. Okay, let's go there. So let's pick our chord. This is the chord. Now, according to the question, if here is the center, this angle 90, 5 centimeter is the radius. We have 4 centimeter from the center of the circle. We don't know L. So here we are given R as 5 centimeter. We are given D as 4 centimeter. L question mark. But because L is what we are looking for, let's write it first. L squared equals D squared. Oh, sorry. We have R squared. R squared equals D squared plus L over 2 squared. R is 5 squared equals 4 squared plus L over 2 all squared. This is 25 equals 16 plus L over 2 all squared. This is L over 2 all squared equals 25 minus 16. L over 2 all squared equals 9. L over 2 equals square root of 9. L over 2 equals 3. L equals 2 times 3 by the time you cross multiply. And the final answer is 6 centimeters. So from there, we can now say that from the question, calculate the length of the chord. So therefore, we can say that therefore the length of the chord is 6 centimeters. That's number 2. Let's go for number 3. Number 3 question goes thus. Number 3 question. So we have example 3, solution first. Yes. Now let's see the solution. The question says that the radius of a circle is 12 centimeters. Calculate the distance of the chord from the center of the circle. Okay, and a chord of the circle is 16 centimeters. Calculate the distance of the chord from the center of the circle, giving your answer to what 1 decimal place. So here is what we are looking for, this side. Easily, we write our R as 12 centimeters. We write the L as 16 centimeters. Then we have the G unknown. But from here, D squared plus L over 2 squared is equal to R squared. Always write your reason in front, please. Always. That is the specification of Y, so that you will not be penalized for even half mark. So G squared is equal to 60 plus 16 over 2 all squared equals 12 squared. We have G squared plus 8 squared equals 144. D squared plus 64 equals 144. D squared equals 144 minus 64. D squared equals 80. So we have D equals square root of 80. Punching the calculator here, I have square root of 80, which is 8.94 centimeter. According to the question, we are to find our answer to 1 decimal place. That is approximately 8.9 centimeter. Then you write your approximation answer there. I mean the approximation denotation there to show your degree of accuracy. So you write it there in front, 1 dp. So you must write that. If you don't write that, you can have issue. So then you see that I always write my answer in word because the question comes in word. So you give it back to them in word. We now say therefore the distance of the chord from the center of the circle is 8.9 centimeter. That's number 3. Number 4. Now let's look at the question. The question says that an isosceles triangle ABC has its faces on a circle. If AB equals 30 centimeter, BC equals 30 centimeter, and AC is 10 centimeter. Calculate the height BM of the triangle. From this, you can see that when they give you 13, 13, you have AB, BC, which means that B is common to the two lengths. The two sides that are equal, B is common. So that means that those that will be the base will be A and C. So for this reason, you know how to draw it. How to draw that? Draw your chord first. Our chord here is the chord. Now let's draw the two sides. Now, from what they said here, like I analyzed the other time, B is common to the two common sides. So here will be B, here will be A, and here will be C. Definitely here is 13 centimeter, 13 centimeter, and the chord will be 10 centimeter. Here is the angle 90. We have to calculate BM. Here is B, here is M here. That's the height. So what do we do here? So easy. From what we are given, if you consider just a triangle there. So let's considering triangle BMC. We have something like this. BMC. Here will be 13 and here will be 5 centimeter. Now to get BM is easy now. So from here we have BC. Length BC is 13 centimeter. Length MC we can see is 5 centimeter, half of the chord. We have to calculate question A, length BM, which is the height of the triangle. And we can easily say that, but length BM squared plus length BC squared, MC, our hypotenuse is BC. BC squared is equal to Pythagoras. Is from what? Pythagoras theorem. So this BM is unknown, plus MC is 5, so MC squared will be 5 squared. BC squared now we have 13 squared. So we have BM squared plus 25 is equal to 169. That is BM squared equals 169 minus 25. We have bm squared equals 144. bm equals 144, and that's 12 centimeter. So with that, we are through with the height bm. So we can just tell them that therefore the height bm is 12 centimeter. Now the next question is to find the radius of that circle. So the radius of the circle is to be calculated now. How do we go about that? That's quite easy. I will show you how to do that. Now, ordinarily, if you draw from the center of the circle here down to this place to be the radius, please don't mind my drawing, please. So that radius here, if here is the center, the radius will also be from here, since from circumference to here is also radius. And just now we've calculated from B to M to be 12 centimeter. I know this place might look cumbersome for some students. If you have issue with that, please just ask me later. Now, here from M here to here is 12. If you want to say radius from here now, from here to here, from the center to the circumference is another radius. But this is not to radius. It remains like 1 to get to the radius. Now, here we have what? From here to here, we don't know it. But from here, from B to M is 12. So since the whole here, from here to here, like this, is 12 centimeter, right? So, but we need this place, only this place to this place. That will be 12 minus R. So that by the time you add 12 minus R to R, you get 12 back. So now, if you now consider B now, says that we should find R. We now just say that considering triangle OMC. Look at that triangle. That small triangle there. Here is 12 minus R. Here is R, 5 centimeter. Again, Pythagoras theorem. Just say, but R squared equals 12 minus R all squared plus 5 squared. Still our Pythagoras theorem. Now here we have R squared equals, some students will just square 12 and R and say minus. No, it's not like that. This is same thing as 12 squared, which is 144, minus 2 times 24 times minus R. That will give you 2 times 12 times minus R will give you minus 24R. Then minus R squared will give you plus R squared. Plus what? 25, which is 5 squared. So if you know how I expand this, it's very simple. What I've done is 12 minus R times 12 minus R. 12 times 12, 144. 12 minus R is minus 12R. Minus R times 12 minus 12R again. Minus R times minus R plus R squared. So we have 144 minus 24R plus R squared. So here, now from here, we can transfer those with R to the other side. So that will give us R squared plus 24R minus R squared Because 144 plus 25 is 169. So we now have plus r minus r squared. We are now left with 24r equals 169. Then from there, what do we get? We have r equals what? R equals 169 over 24. If you divide this very well, you get 7 whole number 1 over 24 centimeter, and you can change it to decimal. Is that okay? I believe that is quite alright with you. Now let's go to, okay, they said to the whole centimeter. So now this is same thing as 7.042 centimeter, approximately equals 7 centimeter. Write your degree of accuracy again to the nearest centimeter. Leave it like that. So we now say therefore the radius of the circle is 7 centimeter. Now let's look at number 5. Now, according to the question, it says that two parallel chords lie on opposite sides of the center of a circle of radius 30 centimeter. Their lengths are 10 centimeter and 24 centimeter. So what are they saying here? It means that we have a chord, like one chord up here, opposite to what? To the center. They are both opposite to the center of a circle. They are opposite like this. And the two of them are parallel. So according to them, to the question, the two of them are parallel. That is, this place is parallel to this. Now, let's put the radius there. Now, we have the radius drawn. Then we still need to draw something again. We need to draw something. Yes. So drawn now. According to the question, the first chord is what? Is 10 centimeter. Second chord is 24 centimeter. They are parallel to each other, and at the same time, they are the opposite side of the center. Center is opposite to one another. So here, the radius is 13 centimeter. 13 centimeter. So from here, we can say that L1 is what? Is 10 centimeter. The length of the chord of the second one is what? Is 24 centimeter. We have to find the distance between the two of them. Calculate the side. Calculate the side of the triangle from the center of the circle. This question is totally wrong. It's totally wrong. The question is totally wrong. I will let me get the question and tell us what we have there. Question is wrong. I pick a question for another one. This is the real question there. Calculate the distance of each chord from the center of the circle. This is the question for that one. That one is a mistake. Calculate. Let me put that one there so that we can be happy. Calculate what is the distance of each chord from the center. So that is what they ask from us, really. So it means that we have to find, and we're given the radius. The radius is 13 centimeter. We have to calculate D1 and we have to calculate D2. So here will be D1, here will be D2. But all we know is that D equals, or D plus L over 2 equals R squared from Pythagoras theorem that we know. By now you should have committed this one into your memory. So D1 here plus L1 over 2 squared equals R squared, and also D2 squared is equal to what? Or plus L2 over 2 all squared equals R squared. Pythagoras theorem is working here. So we have D1 squared plus 10 over 2 squared equals 13 squared. D2 squared plus what? 24 over 2 all squared equals 13 squared. So we have D1 squared plus 5 squared equals 13 squared. D2 squared plus 12 squared equals 13 squared. We have D1 squared plus 25 equals 169. D2 squared plus 144 equals 169. D1 squared equals 169 minus 25. D2 squared equals 169 minus 144. D1 squared equals 144. D2 squared equals 25. D1 equals square root of 144. D2 equals square root of 25. D1 equals 12 centimeter and D2 is 5 centimeter. So we have looked for their distances now from the center of the chord, and that is just the answer. After solving the number 5 question, here is take home question. You can lay your hands on this and submit it to the contact below. If you want to call, you can call me, WhatsApp me on this number. Just send it to me, or send it directly to my Telegram, or to the Telegram group where I discuss most things with students there. There are many people there. You can join them today. So anytime you have question, you can send it there. I will help you solve it. Then this assignment or take home, just do it and send it to me. The first person to get it will have a prize. So you want to join the group? Here is the group here for the Telegram. Any question you have, maths and physics for hours, you can send it there. See you when I see you, and bye for now.